Hello students, welcome back. Let's begin part 3 of Symbolic Logic. This is also the last part of the series on Symbolic Logic, chapter 8 of your textbook. There are 4 common valid forms of arguments that we shall be covering in this chapter. These are exceedingly common and may be intuitively understood. Now, let us identify them precisely, and their names are number 1, disjunctive syllogism, DS, modus ponens, MP, modus tollens, MT, and hypothetical syllogism, HS. The next chapter, chapter 9, is methods of deduction, where we shall learn about 19 rules, the 9 rules of inference and 10 rules of replacement, which we can use to infer the validity of arguments. The 4 forms of valid arguments that we are going to discuss here fall amongst the first 9 rules of inference. As you can see, I have highlighted these 4: modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism here, so that you understand how important it is for you to remember these 4, because you will be dealing with these 4 later in the next chapter also. Modus ponens. The specific form of this argument is written like this: P implies Q, P therefore Q. So here what it means is this, that if the truth of the hypothetical premise is assumed, which means if P implies Q is true and the truth of the antecedent of the premise is also assumed, that is, the antecedent is P. If the truth of P is also assumed, then what will happen? The conclusion, that is the consequent of the premise, which is Q, is also true. So this is the structure of modus ponens, and the truth table shows that it is a valid argument form because the premises, what are the premises? P implies Q and P. These are the two premises, and the conclusion is Q. In it is in not a single case you can see that the premises are true and the conclusion is false, which proves that this is a valid argument form. The next one is modus tollens. Here the argument is symbolized as P implies Q, not Q, therefore not P. So if P implies Q is true and not Q is true, then it follows that the negation of the antecedent is also true. So how are we going to prove it? So let's make a truth table for this argument. The premises are P implies Q and not Q, and the conclusion is not P. So in none of the cases, the premises are true and the conclusion not P is false. Therefore, it is proven that modus tollens is a valid argument form. The third one is hypothetical syllogism. A syllogism that contains a hypothetical proposition as a premise. It contains 3 distinct statement variables, that is P, Q and R. So the truth table must have 3 initial columns and requires 8 rows to list all the possible substitution instances. Besides the initial columns, 3 additional columns are needed, 2 for the premises and third for the conclusion. So what is hypothetical syllogism? It is structured as P implies Q, Q implies R, therefore P implies R. The truth table shows that the premises P implies Q and Q implies R are leading to the conclusion P implies R, and it is a valid argument because it is never the case that the premises are true while the conclusion is false. The next one is disjunctive syllogism. It is a very simple argument form and it relies on the fact that in every disjunction, that is an either or situation, at least one of the disjuncts must be true. Therefore, if one of them is false, the other must be true. And it is symbolized as P well Q, not P, therefore Q. You can see from the truth table over here that it is a valid argument form because the premises P well Q and not P are leading to a valid conclusion which is Q. Now let's move over to the common invalid forms of arguments. Number 1, the fallacy of affirming the consequent. It is symbolized as P implies Q, Q therefore P. This is often confused with modus ponens, which is valid, and which is P implies Q, P therefore Q. But in this fallacy of affirming the consequent, that is, the consequent is Q. And instead of affirming the antecedent, here we are making the fallacy of affirming the consequent, which is Q. So this is a very common invalid form, and it is very common also for students to confuse it with modus ponens. Similarly, we have the fallacy of denying the antecedent. P implies Q. So what is the antecedent? The antecedent is P. And by denying the antecedent, that is by saying not P, we are arriving at an invalid conclusion which is not Q. Whereas the valid argument form is modus tollens, where it is not the antecedent but the consequent Q which is denied, and that leads to the valid conclusion not P. So again, it is important that you do not mix up modus tollens with the above mentioned fallacy of denying the antecedent. Statement forms. Now there are 3 types of statement forms: tautologic, self contradictory and contingent. So suppose you are given an argument and you have to draw a truth table to infer its validity, and there you will see that sometimes the statement form will have only true substitution instances. For example, P will not P. If you draw a truth table of that, P not P, P will not P, you will see that all the instances are true. So where all the substitution instances are true, then the statement form will be marked as a tautology. Now, a statement form that has only false substitution instances is said to be self-contradictory or simply contradiction and is logically false. An example of a self-contradiction is, I will get an A in this class and I will not get an A in this class. So this statement is always false, so it is a self-contradiction. To show that the statement form P and not P is self-contradictory, we construct the following truth table. You will see under P dot not P, there is only F. So all the substitution instances being false, this statement form is marked as self-contradictory or a contradiction. Thirdly, statement forms that have both true and false statements among their substitution instances are called contingent statement forms. They are neither tautologous nor self-contradictory. A contingent statement may be true or false, and a contingent statement form has some true and some false substitution instances. So here is an example. The statement form is P implies within bracket P implies again bracket Q and not Q brackets closed. In order to form a truth table of this statement, we need to construct columns of P, Q, not Q, Q and not Q, P implies Q and not Q, and finally the statement which is given, that is P implies within brackets P implies within bracket Q and not Q brackets closed, which is the 1, 2, 3, 4, this last column. You will see under the last column, which is the statement form, we have derived the substitution instances which comprises both true and false ones. So, having constituting both true and false substitution instances, we can say that this statement form is a contingent statement form because it is both true and false substitution instances. The next example, the statement form is P try bar within brackets P dot bracket P will Q brackets closed. So P Q P will Q P dot within brackets P will Q. These are the four columns that you have to make in order to find the substitution instances of this statement form. You will see under the fifth uh, column, in the fifth column, that is, there you find the statement form which is given. All the instances are marked as true. So having a statement form where all the substitution instances are true, we can safely call this statement form to be a tautology. The third example is a statement form which is self-contradictory because, as you can see, all the substitution instances are false. Now with that, we have come to the end of chapter 8, that is symbolic logic. There is a small answer key linked with this video. Do check that out and also check out the previous PDFs, that is the solution of the earlier two parts of symbolic logic. So that's all for now. In the next video, we'll start chapter 9, that is the method of deduction. Till then, goodbye, take care.